Hello my dear students, welcome back to Learn Physics. In today's topic, we are continuing with our kinematics portion. Last class we were discussing about the non-uniform acceleration method, how we will be finding out the acceleration, velocity, displacement, how we will be finding out how to do the differentiation, integration, that and all we were discussing, right? So today we are going to do the same, the uniform acceleration. In the case of uniform acceleration, how can we write down these equations? Okay, so uniform acceleration, the formulas you know, v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square equals 2as. Okay, using these equations, how can we find out the how can we solve the numericals? Okay, so here first question is, a particle of mass 1 kilogram has a velocity of 2 meters per second. A constant force of 2 Newton acts on a particle for 1 second in a direction perpendicular to its initial velocity. Find the velocity and displacement of the particle at the end of 1 second. And one more thing, I got a comment like if I am writing down the question, or if I am giving the question in the board itself, it will be convenient for you. See children, I have a personal difficulty in typing all these my questions, and for typing it's having some personal difficulties. That's why I'm not typing. So what my humble suggestion is, you can write down the question when I'm reading out the question. That time itself you can pause and write down the question. It will be a practice for you instead of hearing. If you are simply hearing the question anyway, and if you are simply hearing this whole video, anyway it won't be useful for you. If you are writing down and learning and trying to do, then only you can improve. So better you can write down the question and then try to solve by yourself. Then check whether the answer is correct or not. Okay. Here in this, a particle of mass 1 kilogram. So mass is given as 1 kilogram, has a velocity of 2 meters per second. So velocity is given as 2 meters per second. A constant force of 2 Newton acts on a particle for 1 second in a direction perpendicular to its initial velocity. So a constant force is acting. Mass is not changing. If force is constant force, that means acceleration will be constant. That is uniform acceleration. For 1 second, time is given as 1 second. Force is 2 Newton. Find the velocity and displacement of the particle at the end of 1 second. At the end of 1 second, we should find out the displacement and velocity. How can we find out displacement and velocity? Initial velocity is given like 2 meters per second. Time is given 1 second. So since it is a constant force, we can find out acceleration. F is equal to ma. Therefore, acceleration will be equal to 2 by 1, 2 meters per second square. So here the important thing which we need to consider is, here a constant force of 2 Newton acts on a particle for 1 second in a direction perpendicular to its initial velocity. So a force is acting in a direction perpendicular to its initial velocity. So anyway, we need to find out velocity and displacement. And here, so first I am considering the equation of velocity. V equals u plus at. This is the equation. So u is the same dimension like velocity, at has the same dimension like velocity. So how can I find out velocity here? Final velocity I should find out, right? U and at, it is at, forces acting in a direction perpendicular to its velocity. Force means acting in direction perpendicular, means acceleration will be acting perpendicular. So if I am drawing a graph between initial velocity and at, so, and while I am taking see this is u and this is at, then here this vector will be giving you v equals u plus at, parallelogram method, right? U plus at will be here, where you taking the vector addition. u is acting in this direction, at is acting in this direction, then v will be u plus at. How can I find out the velocity v? By taking the vector equation. So here v, resultant velocity v will be equal to root of a square plus b square, that is u square plus at the whole square plus 2at cos 90. Cos 90 is 0, therefore u square plus at square. What is u here? 2 square plus a is 2, t is 1, therefore 2 square. Square root of, so root 8, that is equal to 2 root 2. That is the velocity. Right? Now we need to find out the direction of velocity is a vector quantity. So we need to find out the direction. How can we find out this direction? Tan theta equals, you can find out this theta. Tan theta equals opposite side divided by adjacent side. Opposite side is at divided by adjacent side is u. At is 2 into 1 divided by 2, therefore 1. Therefore theta we will be getting it as 45 degree. So velocity is 2 root 2 meter per second is its velocity, and acceleration is theta is 45 degree. It will be making an angle 45 degree. Okay, this is about the velocity. Now can you can you find out the displacement? Displacement equation we know S is equal to ut plus half at square. To find out S, what we can do? We can draw the vector for ut and at square. See, this is ut and this is half at square. Then this will be the velocity, the displacement vector. Displacement vector, how can I find out? Vector root of ut square plus half at square the whole square plus 2ab cos theta. Cos 90, that is equal to 0. Therefore, we will get it as ut. What is ut value? 2. 2 into 1, 2 square plus half into at square. A is 2, t square is 1. Therefore, 2 half the whole square. So here we will be getting 4 plus 1 root 5 meter. This is the displacement. As in the previous case, since displacement is a vector quantity, we can find out the direction also by finding out theta. Tan theta will be equal to half at square. That one we got it as 1 divided by ut. Ut we got it as 2. Tan theta is half, that is theta equals tan inverse 1 by 2. So this is how we will be finding out the equation. Clear? So forces acting perpendicular. Forces acting perpendicular to initial velocity means acceleration is acting perpendicular to initial velocity. Clear? So the next question is, the velocity and acceleration of alpha particle at time t equals 0 are u equals 2i plus 3j and a equals 4i plus 2j meter per second square respectively. Find the velocity and the displacement of the particle at time t equals 2 seconds. So velocity of the particle at time t equals 0 is given as, so initial velocity is 2i plus 3j meter per second. Acceleration is 4i plus 2j meter per second square. That means it is not varying with respect to time. In acceleration we got it as 4i plus 2j. It is not varying with respect to time. So it is uniform acceleration. Find the velocity. Which formula we can use? V equals u plus at. And find the acceleration. Velocity and displacement. S is equal to ut plus half at square. We can use it and find out the final answer. So at time t equals 0, velocity is given. That is initial velocity is 2i plus 3j meter per second. Acceleration equals 4i plus 2j meter per second square. That is acceleration. Find the velocity and the displacement at time t equals 2 seconds. When t equals 2 seconds, What is the velocity? V equals u plus at is the velocity equation. S is equal to ut plus half at square is the displacement equation. First we will do V equals u plus at. We need to find out the final velocity and displacement. V equals, what is the value of u? 2I plus 3j plus A is 4I plus 2j into 2 seconds. After 2 seconds only it is asked. So into 2. Here you can do it as 2I plus 3j plus, you should multiply each I with 2 and j with 2. Here 8I plus 4j. And then add I together, add j together. So here it is 10I plus 7j. That is the velocity. Same way we can find it for displacement also. S is equal to u is 2I plus 3j into 2 plus half into 4I plus 2j into t square, that is 2 square. So here 4I plus 6j plus 8I plus 4j. So here we will get it as 12I plus 10j we will get. Okay, this is about the 12I plus 10j, that is the displacement, and velocity is 10I plus 7j. Clear? Next is here unit, you should write down unit also, meter per second. This is in meters. So it is 12I plus 10j. Next question is, velocity of a particle in xy plane at any time t is v equals 2ti cap plus 3t square j cap meter per second. At time t equals 0, particle starts from the coordinates 2 meter, 4 meter. Find acceleration of the particle at time t equals 1 second, position vector and coordinates of the particle at time t equals 2 seconds. So here velocity is given. Okay, and when we started, velocity of the particle is given as 2t I cap plus 3t square j cap. That is, velocity is changing with respect to time. 2t plus t also there, right? So at time t equals 0, the particle, the velocity coordinates are, starts from coordinates 2 meter, 4 meter it is given. Okay, in the initially velocity, the particle's displacement is given like 2 meter, 4 meter. Then acceleration of the particle we need to find out at time t equals 1 second. For that, from velocity you can first find out acceleration. Whether is it depending on time or not, then we can find out. While finding out that if t is present in the acceleration, then it is a non-uniform acceleration. If it is under non-uniform acceleration, we can't use any of these formulas. And time t equals, what is that, 1 second we can substitute and find out acceleration. Same way, find out the position vector also. Then by subtracting this 2 meter, 4 meter, we will be getting, by adding those 2 meter, 4 meter, we will be getting the final position also. So in the question, velocity v equals 2t I cap plus 3t square j cap meter per second. At time t equals 0, particle starts from the coordinate. Coordinates are 2 meter, 4 meter. Find acceleration of the particle at time t equals 1 second. That is the first one. Second question is position vector and coordinates of the particle at time t equals 2 seconds. Position vector also, R also we need to find out at time t equals 2 seconds. Okay, first we can go for the acceleration. Find out the acceleration from velocity. How we will find out? Differentiating. Acceleration equals dv by dt. Okay, 2t d by dt of 2t I cap plus 3t square j cap. That is 2i plus 60j. 2i plus 60j. T equals 1 second means we will get it as acceleration equals 2i plus 6j cap. So it is a factor which is depending on time. So it is not uniform acceleration, it is non-uniform acceleration. Acceleration is changing with respect to time. Okay, so acceleration value 2i plus 6j meter per second square we got. Now we will move to the position vector. How to find out the position vector here? We have velocity. If we have velocity, from that to find out the position vector, we should integrate. So now r equals integral. How we can find out the velocity from velocity vector? Integral v dt. How we will get this? Last class I told you v is equal to dr by dt. Therefore dr equals v into dt. R equals integral v dt. What is the value of v here? V is 2t I cap plus 3t square j cap dt. Integral. So different integrating, we will get it as 2 into t to the power n plus 1 divided by n plus 1 t square by 2. 2 into t square by 2, t square I cap plus t cube by 3 t cube j cap. What is the limit of integration? Till 2 seconds. Therefore 0 to 2. 0 to 2 when we are substituting 4i plus 8j we will get. That is r. What is meant by this position vector r? Displacement r equals this much. That is, displacement means initial final position minus initial position. That is equal to 4i plus 8j. So what will be the final position? 4i plus 8j plus r0. R0 here it is given like initial position as 2 meter, 4 meter. That is 2i plus 4j. This is x coordinate and this is y coordinate. 2i plus 4j. Therefore, we can add 2i plus 4j to that. Therefore, it is equal to 6i cap plus 12j cap. 6, 12. This is the new position of the particle. Clear? Next question is, velocity of the particle at any time t is v equals 2i plus 2t j cap. Find acceleration and displacement of the particle at time t equals 1 second. Can we apply v equals u plus at or not? Velocity is given like 2i plus v equals 2i plus 2t j cap. Okay, meter per second. Acceleration, first we can find out the acceleration. Acceleration means differentiation of velocity will be acceleration. So while differentiation of 2i will be a 0, because since it is a constant it will be 0. 2t I cap, differentiating dt 2t, we will get the value as 2. So acceleration won't be changing with respect to time. That is, it's under uniform acceleration. We can substitute the value of v is equal to u plus at over there. Okay, shall we do? So here v equals 2i plus 2t j cap meter per second. Find acceleration and displacement at acceleration and displacement at time t equals 1 second. We need to find out. We know that acceleration equals dv by dt. This is the acceleration. So what is dv here? dv equals a dt. Right? So here how we can find out the velocity? V equals integral dv. Velocity, initial velocity is 2i, final velocity we don't know. We need to find out. That is equal to integral a dt. Time is changing from 0 to 1. So what is integral dv is v. We can apply 2i to v. A dt, a is 2t, 3t square. While integrating, we will be getting it as t square I cap plus t cube j cap we will get in 0 to 1. Substituting both the values, we will be getting it as v minus 2i will be equal to 1 I cap plus j cap. I cap plus j cap. Therefore, v will be equal to 2i plus I cap plus j cap. Therefore, 3i plus j cap. The same way we can find out for displacement also. See, if we know the acceleration or velocity, since we know the velocity, how can we find out the displacement? Displacement equals dr equals v equals dr by dt. right? Therefore dr will be equal to v dt. R is equal to integral v dt. For finding what is v here and all we substituted 1, right? T equals 1. Before substituting 1 we will be getting it as v minus 2i, that is equal to t square I cap plus t cube j cap. So what is v here? 2i plus t square I cap plus t cube j cap. Therefore we can write r is equal to, r is initial position minus final position, sorry, final position minus initial position will be equal to integral, what is the value of 2i plus t square I cap plus t cube j cap. So velocity, how it is changing, it is from time displacement position t equals 1 second. So 0 to 1 second. Here we will be getting it as 2t I cap plus t cube by 3 I cap plus t to the power 4 by 4 j cap. Substituting 1, we will get it as 2i plus 1 by 3 j cap, I cap plus 1 by 4 j cap. So here we can write it as 7 by 3 I cap plus 1 by 4 j cap. So the values are 7 by 3 and 1 by 4 is the final position displacement of the particle. Coordinates are 7 by 3 and 1 by 4. Initial position is not given over here, right? Then we could have substituted that also. It's not given. Okay, clear? So this is how we will be finding out the position vector. Okay, I hope it is clear for you, and I'm winding up for today. Next video we will be coming along with the new portion, that is graph in kinematics here. And if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.